This is Mrs. Berg. So this is the first lesson that we're going to be doing together. Um, so a couple of things I want to tell you guys about is the extra help rooms, which will be Monday and Wednesday. They're going to be in D112 and in D136. Miss Devon and Mr. Gracia are going to be waiting for you guys. If you have any questions after the lesson, you can always go and talk to them and ask them. Okay, so today's homework is 9-1. It's attached to the back of the packet that you picked up when you walked in. And we're going to be talking about scale factors today. So what are scale factors and how do you dilate a polygon? So those are the two uh, goals that we have to meet by the end of the lesson. Okay, so the first thing we want to do is want to talk about some definitions here that we have to know. So let's talk about what a dilation is. Okay, so a dilation is a transformation. So we've talked about transformations before, but a dilation is different because the transformations that we've talked about are range of motions where nothing changes. Everything is the pre-image and the image are going to always be congruent. But in a dilation, in the the pre-image, what's going to happen is going to enlarge or is going to shrink the size of the figure. Okay, so it's going to actually affect how the figure looks. So if you go to the right side here and you take a look at these two figures, the pre-image is ABC and the image is A prime, B prime, C prime. So as you can see, the actual length of the sides have changed. So it's enlarged. And something else is really important that we have to know about. It's called the center of dilation. The center of dilation is usually center of dilation. The symbol is going to be C. So they use the letter C for the center of dilation. What is the center? The center is really, really important. So I'm going to put little stars around here. So what we're going to do in this lesson, the next couple of lessons, is we're going to take a look at the center of dilation, and we're going to measure the distance to the pre-image and the distance to the dilation image, and we're going to make something called a scale factor with those two distances. But the point of the center of dilation is it's a really important point. It's a point of reference, if you will. Okay, so the shape will expand from this point or it's going to shrink from this point. So that's why it's really, really important. Okay, and we're going to talk about that in a little bit. Something else we have to know, another term we have to be really good at is, or we have to understand, is called the scale factor. Okay, the scale factor is actually a ratio. It's a ratio of the distance length of the image over the pre-image. That's really, really important. So you have to remember image over pre-image. That's really, really important when it comes to the scale factor. It's got to be in that order. So it's got the image over the pre-image. And the symbol that we use for the scale factor is K. All right? So there's a couple things that we have to also understand. So there's some facts that we have to be really good at. So when we talk about dilation, since the corresponding sides are multiplied by the same scale factor, then the pre-image and the image actually will always be similar. And the reason why is because the sides will always be proportional. So if three pairs of sides are proportional, then we use size, 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 similarity. Okay, makes sense. So when I dilate, I create similar figures, not congruent, but similar, because the sides will be proportional. The center of dilation, um, so when I look at the center of dilation, the um, and then I look at the pre-image point and its corresponding image point, they're all something that we call collinear. Okay, so if you go down to the picture here, let me show you what I mean. So here's the center at O. That's the center of dilation. Here's the pre-image and here's the image. So if I draw a line connecting these 3 points, then they will all be on the same line. So that's how I recognize where the center is. The center is always going to be collinear with the image and the pre-image. So I should be able to draw a line straight through those 3 points if that's a dilation. Okay? So what does collinear mean? Collinear means that they are on the same line. Okay, now let's talk about the notation. Notation for dilation is capital D, and the subscript will always be first the point, the center of dilation. So we're going to say C, and then the scale factor, K. So it tells me where to dilate from and how much to dilate by. So that's really important. So it's going to look something like this. Capital D, center, and then the scale factor, let's say it's 1/2. It's going to look something like that. So this is an example of what it might look like. Okay, so let's take a look at scale factor because it's really important. So the scale factor is always a ratio. Okay, so it's a ratio of the length of the pre-image. So from the center to the pre-image, and from the center to the, from the center to the image. So it's always image over pre-image. So let's write that down here. So image. So what are you doing here? You're finding the distance from the center to the image, right? So it's the distance of the center to the image. And I'll show you what that looks like in a little bit. Over the pre-image. Image over pre-image. And this is the distance of C to pre-image. Okay, so remember the image is the ones that have the primes. So that's like A prime, B prime. That's the images. It's after the transformation has happened. That's called the image. Okay, so let's practice. Determine the scale factor of the following dilation. So if I look at the first example here, here's my center. And when I look at the 2 figures here, and if I'm looking at, let's start with point P. This is my image. I'm sorry, that's a pre-image, and this is the image here. And so we start here. This is the pre-image, and that we land here. That's the image. So if I'm looking at the scale factor, what I want to do, if I'm starting at C, I want to look at the distance from the center to the image. So we're looking at this is from the center to the image. So that has to be 12. That will be 12. And then from the center to the image, the pre-image, sorry, center to pre-image. So the center to here, where we started. So that's going to be 8. You can simplify, you don't have to, but you can simplify. That simplifies to 3/2. Okay. All right, so now let's try another one. Here's example B. Here's my center. Here is my pre-image, and here's my image. So remember, it's always image over pre-image. So we're going to start here from the center to the, from the center to the image. So from here to here, what's that distance? From the center to the image, it's going to be 18. And then from the center to the pre-image, it's going to be 30. So it's 18 over 30. Simplifies to 3/5. Okay, so it's always from the center to the image over from the center to the pre-image. So in order to memorize it, you just have to remember it's image over pre-image. Whatever the image is, over the pre-image. Okay. All right, so let's take a look at what we're going to do next. Okay, so now in terms of the scale factor, so when the dilation made the pre-image bigger, so if I'm making something bigger, then the scale factor has to be greater than 1. So K has to be greater than 1. K is the scale factor. So if you look at the scale factor and it's a whole number, if it's bigger than 1, then it's going to be something that we call an enlargement. greater than 1. So the scale factor is greater than 1, then you're going to have an enlargement. If the dilation made the pre-image smaller, then the scale factor has to be less than 1, which usually means that it's going to be some type of fraction. So one way to check to see if you've done a good job in your dilation is to look and see if the scale factor is less than 1, then your image should be smaller than the pre-image. It just depends on the scale factor if you did a good job. So it's a good way to check your work after you dilate. Okay, so now let me show you how to dilate. So now that we know what a dilation is, we can actually take a figure and dilate it by using this method that I'm going to kind of walk you through. Okay, so let's take a look at what we have here. So it says graph triangle PQR with the following vertices and its image after a dilation of scale factor 3. So that is going to be K, and the center of dilation at 0, 0, which is the origin. That will be my C. So the first thing you want to do is you want to graph your center of dilation. So we're going to plot it right here. There's my center. I'm going to call that C. It doesn't have to be called C. Sometimes they call it something different, but for this case, they don't give it a name, so we're going to call it C. All right, so now there's going to be a lot of counting that happens on the coordinate plane to do this. So I want to make sure that you guys are okay with graphing, and make sure that you're plotting correctly. Otherwise, it's not going to make sense when you're counting. Okay. All right. So here's what we're going to do. We're going to take a look at each of the points. So let's start with point P. P is, let's see, 0, 2. P is 0, 2. Q is 1, 0. And then R is 2, 2. Okay, so let's go ahead and graph the pre-image. 0, 2. That's P. Then we have 1, 0. That is Q. And then you have 2, 2, which is R. Okay, so I should be able to see let's make the center a different color so we don't, here's the center here. Okay, so the pre-image looks like this. There's my pre-image here. Let's do a better job at this. Hold on one sec, guys. Let me connect that a little bit nicer for you. Okay, so here's my pre-image. Now, here's what we're going to do. So what we want to do is we always want to count from the center of dilation. So you always want to start counting from the center. You always go back to the center. This is really important. You have to go back to the center. You cannot count unless you're starting from the center every single time. So what you want to do is you want to count the rise and the run from the center to each of the pre-image points. So let's start with point P. Okay, so here's P up here. From C to P. So I'm counting to see if I'm going up or down. That's what we call the rise. So we're going 1, 2 up. So I'm going to come over here, I'm going to write 2. And it's positive 2 because we're going up 2. And then we're not moving right or left to get to P. There's no run. So I'm going to call that 0. Okay, now we take a look at the scale factor. So what we do next is we multiply the distance by the scale factor. The scale factor we said was 3, right? So we're going to come back here, and each of those distances we're going to multiply by 3. So you're always multiplying by the scale factor to get the new distance. So if I do 2 times 3, I get 6. And if I do 0 times 3, I get 0. So what do these numbers give me? This is the new distance from C, right? So if I look at this, I'm going to go now, if I go back to the center, always go back to the center. The new rise is going to be 3. So from C, I'm going to go up 3. 1, 2, I'm sorry, 6. I'm going to go up 6 because that's the new distance, right? So let's count 6. 1, 2, 3, 4, 5, 6. So that is where P prime is going to land. And there was 0 run, right? So I didn't go right or left at all because the run was 0. So now here's how you can check to see if you did a good job. Are C, P, and P prime collinear? Can I draw a line through them? Yes. So then I did a good job. Okay, then you do the same thing with Q. So if I go to Q, I'm going to count. Okay, so it's rise over run. Am I going up or down at all? I'm not. To get to Q, I'm staying here, right? So there's zero rise here. And then the run, I'm going over to the right side 1, so it's positive 1. So if I go right is 1, if I go left is negative 1. So keep that in mind when you're counting, okay? And again, I'm multiplying the distances by always the same scale factor. So I do a little bit of math here. This will be 0, this will be 3. So again, very important. Always go back to C. From C, now I go the new distances. So I'm not gonna rise at all because it's 0. So I'm not gonna go up or down, but I am gonna go right 3. 1, 2, 3. 1, 2, 3. So here's my new point here. Here's gonna be Q1, Q prime. There's Q prime. Okay, double check. Are the center of dilation, the pre-image, and the image collinear? Yes, they are. So I did a good job. Okay, so now let's do the last point here. We have R. From C, go back to C. From C to R, we're going to go up 2, so that's a rise of positive 2. And then we're going to go to the right 2, so it's a run of 2, positive 2. Up 2, right 2. Now multiply by the scale factor, and I get my new distances from C. Right, so from C, now I count 6 rise, so I go 1, 2, 3, 4, 5, 6, and then 6 run. 1, 2, 3, 4, 5, 6. There's my new point here. This will be R prime. Okay, now I check. Is the center, the pre-image, and the image collinear? Yes, then I did a good job. Okay, so now I can connect my points here. Oops. Bear with me here. It's kind of hard to do. Oh, this pad here. There we go. Okay, now, what are my new coordinates? So go back and just look and see what the new coordinates are. They're going to be 0, 6. They're going to be 3, 0. And we're going to have 6, 6 here. So here's my image points here. Okay, now look, the scale factor was 3. Is 3 is greater than 1. So doesn't it make sense that our shape got bigger? Because that's an enlargement when the scale factor is greater than 1. So you always want to kind of double check. You want to check to see, number 1, if the 3 points are collinear, the center, the pre-image, and the image. And then you want to check to see if your scale factor was greater than 1 or not. Did my shape get bigger or smaller? So that's really, really important to check there. Okay? All right, so now let's take a look at the next couple pieces here. I'm going to do this with you guys. Okay, so now something really important happens when you dilate, which is really cool. When I look at the corresponding sides, so if I look at PR and then I look at P prime, R prime, those are the two sides that are corresponding, right? Because this is before, this is the pre-image, and this is the image, right? Something cool happens when you dilate is that if I look at the slope of this segment versus this segment, the pre-image and the image, they're always going to be the same because their slopes are the same. That means that they are parallel. So it doesn't matter which pair of sides I look at as long as they're corresponding. So this side will be parallel to this side, right? And then this side, the last side, will also be parallel to this side because of the dilation. So the dilation, what we say is that it preserves parallelism, or that it keeps the sides that are parallel parallel, and it also the segments will, the pre-image segment and the image segment will always be parallel to each other. So what are the things that we notice? That PR, which is the pre-image, is going to be parallel to P prime, R prime. Okay, they're always the same slope. They have the same slope here. Okay, so now when a figure is dilated, corresponding sides between image and pre-image will always be parallel. Always, always. Okay, so that's another way you can check to see if you did a good job. Okay, any questions? Well, if you do have questions, please go to, I can't hear them now, but go to Extra Help. Go to Extra Help and with Ms. Divine or Mr. Gracia, and they'll help you out. Okay? All right, so now what I want you guys to do is to actually practice now. So go next to, go sit next to someone if you want, and work on the practice problems. The keys are online, so you can always check them online, okay? All right, guys. You'll hear my voice again tomorrow. Make sure you go to extra help if you didn't understand something, okay? And watch the video again. Bye. Bye.